Okay guys, welcome to a new section. This is a section on variation, and this is chapter 8, lesson 9, direct variation. Okay, we are gonna suppose that there's a situation where you have, let's say, a ticket. Each ticket costs $4. Wow. Okay, it's like a little carnival raffle or something. Okay, now if you buy one ticket, you pay $4. If you buy two tickets, it costs $8. Three tickets, $12. You see where this is going? Okay, what we're going to say is that there's a relationship between the number of tickets and how much money you spend. If you get more tickets, you get more money. And even more specifically, if you double the tickets from 1 to 2, then you double the money. If you triple the tickets, you triple the money. This is a relationship called direct variation. Okay, what if you do 5 times the ticket? Then you do 5 times the money. Direct variation allows us to say that when you have something, let's say a T and D for dollars, what we're going to say is that the dollars vary directly as the tickets. Okay, this is called direct variation, and what we can say is that you have something, Y, varies directly as X. That's how I would read this. Y varies directly as X. And this is the number that you multiply the X by to get the Y. This is a new way of talking about something that's you already know about. It's just the vocabulary is going to be tricky. So if I say something varies directly, then you have to remember Y equals KX. Let's do a little example. Suppose I say that M varies directly as N. Okay, M varies directly as N. What that means is that M is equal to something times N. You can immediately make an equation. Now, suppose I say that M is 42 at the same time that N equals 2. Can you figure out what the K is going to be? Yes. Let's plug in the numbers. 42 is equal to K times 2. Well, you can see right away that K has to be 21. This K is called the constant of variation. So can you find the constant of variation if I tell you that two quantities vary directly, and then I give you an example set of the two numbers? Yes, you can by plugging it in. See, K equals 21. Now, suppose I say if M varies directly as N, and M is 42 when N equals 2, can you find what M is when N equals 3? Well, yeah. What we're going to do is we're going to take our equation. So M is equal to, and we figured out the K, 21 times N. They gave us the N. M equals 21 times 3. We did it. Okay, so you're going to be doing stuff like that. Now, we're going to do it again, but from another angle. Think about it like this. You know how we're using Y equals, Y varies directly as X. Now, X's and Y's come in ordered pairs, right? So suppose I got X1 and Y1, X2 and Y2. Now, you know that if I plugged in this X and the Y like this, then Y1 is equal to K times X1. It's got to work. And Y2 is equal to K times X2. It's got to work. Now, if I divide both of these things by x, look what happens. I get k is equal to y1 over x1. Well, if I divide this one, then I get k is equal to y squared over x, or excuse me, not squared, y2 over x2. The k's stay the same. So what I can now do is create a proportion. y1 over x1 is y2 over x2. They're the same. So you can say that these are proportional. Okay? These are proportional. Y is directly proportional, or directly proportional to x. Y is directly proportional to x. And then k is also called the constant of proportionality. Okay? There's two ways to look at these things. You can always do it the first way, but sometimes recognizing that you can set up a proportion might be helpful. I'll show you an example. Suppose you're doing like a banking, interest, money kind of a problem, and you say the amount of interest is directly, here's that vocabulary, directly proportional. It's directly proportional to the amount saved. And let's see if that makes sense. The more you save, the more you get interest. Okay, so let's give some variables. Let's say the amount of interest is I, and the amount saved is D for dollars. Okay, you have $104 of interest, and then $1,300 saved. So what we're going to say is that the amount of interest is directly proportional to the amount saved. Now, how much will we earn on $1,800? What's the interest? Well, because we can set up a proportion, let's go ahead and throw it all together. 104 over 1,300 is some other interest over 1,800. Y over x is equal to y over x. Now, we'll use our cross multiplying. 1,300i equals 1,800 times 104. Then we divide by 1,300. So 18 times 104 divided by 13. I is going to be $144 of interest if they save $1,800. We did it. Now you can solve this one without the proportion by doing the y equals kx, plugging in, or in our case it would be interest equals k times d, plugging in your interest, 104 equals k times 1,300, and then dividing by 1,300, so k would then equal 104 1,300ths, which I'm not going to do right now, but you get the idea. And then you plug it in. Interest is equal to 104 1,300 times the $1,800 for the new one, and then you'll get the same thing, $144. Okay, let me know if you have any questions, and you guys do it.